What are the basic principles of software test estimation, and how do they form the foundation of your estimation process? The answer lies around scope, historical data, risk-based estimation, complexity, effort, resources. Let's see how as below. What is work breakdown structure, WBS, and how does it help in estimating software test efforts? Work breakdown structure is comprised of task decomposition, resource allocation, dependencies, time allocation, tracking progress. Check the details below. Let's see an example of work breakdown structure. For a web application project, I would break down the testing tasks as follows. 1. Test planning, 10 hours. 2. Test case design, 30 hours. 3. Test environment setup, 20 hours. 4. Functional testing execution, 50 hours. 5. Regression testing, 40 hours. 6. Reporting and documentation, 15 hours. By breaking down the project into these tasks, we can estimate a total of 165 hours for testing, and track progress more effectively. How do you incorporate buffer time in software test estimation, and what factors influence how much buffer time to allocate? Buffer time is extra time added to the original estimate to account for unforeseen events, delays, or scope changes during the testing phase. Buffer time is essential to manage the unpredictability of software testing. Here's how I incorporate it, as below. For example, for a new mobile app that integrates with third-party APIs, I would estimate the functional testing phase to take around 100 hours. Given the high risk of integration issues, I would add a 25% buffer, 25 hours, increasing the estimate to 125 hours. This buffer ensures that any unforeseen delays or issues with API integrations are accounted for without affecting the overall project timeline. How does function point analysis, FPA, work in software test estimation, and how do you apply it to determine the complexity of software testing? Function point analysis, FPA, is a technique used to estimate the size and complexity of a software system by analyzing its functional components. It quantifies the functionality from the user's perspective, which helps in estimating testing effort. Check the details below. Example, in testing a simple e-commerce website, I could assign function points to different features. User login, 5 points, simple. Shopping cart, 10 points, moderate. Payment gateway integration, 15 points, complex. If the total function points are 30, I could estimate that testing for this will require 150 hours of effort, using a conversion rate of 5 hours per function point. This helps in giving a more accurate estimation for the time needed. What is the role of historical data in software test estimation, and how do you apply it to forecast testing efforts? Historical data provides valuable insights into previous projects that help in predicting future testing efforts. By analyzing similar past projects, I can identify trends and patterns that aid in accurate estimation as below. Let's see an example. If I previously worked on a project involving a similar web application with 50 features, and it took 200 hours to complete functional testing, I would use this as a baseline for a new project with similar scope. Even if some features have changed or added, this historical reference helps to adjust the estimate accordingly, ensuring that I'm prepared for the same or more significant effort. How does risk management impact software test estimation, and what factors do you assess when estimating effort for high-risk components? Risk management is essential in software test estimation because it helps to predict and mitigate uncertainties that could impact testing efforts. I assess the following risk factors when estimating testing time. Here is one quick example. On a cloud-based CRM system, integration with external data sources could be risky because of potential data format mismatches. I would estimate an additional 30% buffer time for integration testing, and also allocate time for post-deployment testing to ensure that integrations work as expected in a live environment. How do you construct a work breakdown structure, WBS, for software testing estimations? And what elements should be included to ensure all necessary tasks are accounted for? The work breakdown structure, WBS, helps break down the testing process into smaller, manageable tasks, allowing for a more accurate estimation. Here's how I would approach constructing a WBS. Let's see, how do you construct a work breakdown structure? What are the elements need to be considered and included? Check below. Test planning. Test design. Test execution. Defect management. Test reporting. Go through the details of each of those. Now let's understand what role does buffer time play in software test estimations. Buffer time is added to the original estimates to accommodate unforeseen risks or uncertainties that might arise during testing. The process of determining an appropriate buffer involves checking following. First one is risk assessment, next is complexity, and lastly by understanding stakeholder expectations. Check the details for each as below. Now let's implement this and check an example. How should we consider an appropriate buffer for a project with high uncertainty? Check the detailed steps as below. How can function point analysis, FPA, be applied to software test estimations? What metrics derived from this technique can significantly enhance estimation accuracy? Check the detailed as below. If I'm testing a new invoicing module, I perform FPA to break down the module into distinct functional components. User input forms. Data validation rules. Invoice generation. And report generation. Based on the complexity, I rate each component, e.g., data validation might be average complexity, invoicing generation might be complex. If the total function points at up to 50, and historical data suggests it requires 4 hours of testing per function point, my testing estimate would be 200 hours. By breaking it down into function points, I gain a more precise estimate of the testing effort required for this specific module. How does the use of historical data influence the accuracy of software testing estimations? And how can teams leverage past project data to forecast future testing efforts? Check the detailed as below. How does risk management factor into software testing estimations? And how can you incorporate risk-based estimation techniques to ensure high-risk areas are adequately tested? Check the detailed as below. Let's see how. The important steps are: identify high-risk areas. Prioritize testing. Risk mitigation. Check example below. While testing a healthcare application, the data privacy and payment integration components are identified as high risk. For these, I allocate additional resources and testing time to cover encryption, compliance checks, and API reliability. This might add an extra 20% to the original estimate to ensure adequate coverage of these critical components. What are the principles of agile estimation in software testing? And how can testers incorporate practices like story points and velocity to improve estimation efficiency? Check the detailed as below. In agile estimation, testing is done iteratively with continuous feedback, and story points help measure the complexity of tasks. Here's how I would incorporate agile principles. Story points and velocity. What role does the testing environment play in software test estimations? And how do you account for setup, configuration, and maintenance time in your estimates? Check the detailed as below. How do you factor in the testing strategy while estimating the time and resources for a project? Check the detailed as below. How do you use baseline test data to improve the accuracy of software test estimations? Check the detailed as below.